Dear First Secondary, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have the last lesson in the algebra. The lesson is Unit 1, Lesson 7. The lesson is called Quadratic Inequality in One Variable. In this lesson is we are going to continue the idea that we have studied in the last lesson. Last lesson, as we studied the sign of the function, we had the sign of the function negative, positive, and 0. Today we are going to study a specific part of this sign of the function. For example, if he asks me about the function greater than 0, so we need the positive sign. Smaller than 0, so I need the negative sign, and so on. Let's start the lesson. Okay, I'm going to start with example 1 direct. Find in R the solution set of each of the following inequality. Okay, x power of 2 plus 2x minus 8 greater than 0. Okay, in this example, I'm going to find the sign of x power of 2 plus 2x minus 8. Okay, but now he asked me the function here greater than 0. So I need what? First, I'm going to do the following. I'm going to make x power of 2 plus 2x minus 8 equal 0. And I'm going to find the roots of this equation. The roots of this equation are negative 4 and 2, x equal negative 4 or x equal 2. Okay, of course, by using the calculator or by using the general formula, it's up to you. Then I'm going to draw the number line as we studied in the last lesson. Okay, here we have negative 4 gives me 0. And 2 also gives me 0. Okay, remember with me, this is a quadratic equation. The quadratic equation, the middle part included the opposite of x power of 2. X power of 2 here is positive, so here the positive. Okay, outside we have the positive sign. Okay, now we need what? We need the sign is negative between negative 4 and 2, positive from negative infinity to negative 4, and from 2 to infinity. Okay, I need what? I need the function at x, at the function greater than 0. Greater than 0 when the function is positive. Okay, so I'm going to take the positive part only. So x power of 2 plus 2x minus 8 is greater than 0 at x belongs to R minus in between from negative 4 to 2. And here I'm going to make it closed because I don't need the negatives or the zeros. So I need the positives only. Or you can write it as negative infinity to negative 4 opened, union 2 opened to infinity opened. Both are correct. Let's start the next example. Number 2, x power of 2 plus 3x minus 4 greater than or equal 0. As usual, I'm going to find the zeros. Okay, x power of 2 plus 3x minus 4 equal 0 at x equals negative 4 and x equal 1. There is a zero, they are the zeros of the function. Okay, the number line here negative 4 and here 1. Okay, negative 4 gives me 0 and 1 gives also 0. In between there are the opposite to x power of 2, which are the negative, and outside we have same as x power of 2, which are the positive. Okay, I need what? I need the function greater than 0 and equal to 0. So I need the positive and 0. Again, I need the positive and 0. So x power of 2 plus 3x minus 4 is greater than or equal 0 at, okay, from negative infinity to negative 4 closed, because I need the value which makes the function equal 0, and from 1 closed to infinity opened, or r minus the negative, which negative 4 and 1. Okay, r minus from negative 4 and 1, but here I'm going to make it opened. Why opened? Because I need the positives and the zeros. Okay, the next example. Number 3, 4 minus 3x minus x power of 2 greater than 0. Okay, at 4 minus 3x minus x power of 2 equals 0. So x equal 1 and x equal negative 4. They are the zeros of the function. The number line here negative infinity, infinity, and in between they are negative 4 and 1. This is 0 and also this is 0. In between, the opposite to x power of 2, x power of 2 here is negative, then in between there are the positive sign, and outside we have the negative sign here and here. Okay, so I need what? I need the function at x greater than or equal to. So I need the positives and the zeros. The positive between negative 1 and negative 4 and 1. The zeros are negative 4 and 1. So f of x is greater than or equal to 0 at x belongs to from negative 1, from negative 4 closed and 1 closed. Number 4. Here 5x minus x power of 2 minus 6 equals 0. Let 5x minus x power of 2 minus 6 equal 0. First, I need to arrange this expression like this. Negative x power of 2 positive 5x minus 6 equal 0. Here, a equals negative 1, b equal 5, c equals negative 6. Therefore, x1 equals 2 and x2 equals 3. This is the roots by using the calculator. Okay, here we have negative infinity, infinity, and in between there are 2 and 3. Okay, here the 0 value of the function, and here also. Here we in between we have the opposite to x power of 2, then the positive lie in between and the negative lie outside. Okay, I need the function less than 0, f of x less than 0 at what? At, I need the 0 only. Okay, so I will write it from negative infinity to 0 opened, and from 3 to 2 opened, and from 3 to infinity opened, or r minus from 2 to 3 but closed. Okay, so I will write r minus from 2 and 3 closed. Okay, the next one here, number 6, number 5. 5x power of 2 plus 12x greater than or equal 44. So first I need to make it the right side 0, so I will replace the position of 44 to the left side. So 5x power of 2 plus 12x minus 44 equal to 0. So x equal negative 4.4 and the other x equal 2. Okay, now here from negative 4.4 and 2, don't forget infinity and negative infinity. Negative infinity is not clear. Okay, here the 0, and here we have also the 0. Okay, in between, opposite to x power of 2, x power of 2 here is positive, then in between we have the negative sign. Outside we have same as x power of 2, which is positive sign. Okay, now we need what? We need f of x greater than 0 or equal 0. So f of x greater than or equal 0 at x belongs to what? The greater than or equal 0. So I need the positive plus the 0 and the positive plus the 0. So I will take all r except the negative. So the negative will be opened. R minus the negative. So the negative will be opened. Negative 4.4 and 2 opened, of course. Now we have the last example, number 6. Number 6, x plus 3 all power of 2 less than 10 minus 3 open bracket x plus 3. Okay, now I'm going to expand the brackets, so it will be x power of 2 first times second times 2, again first times second times 2, it will be 6x plus second power of 2, which is 9. Okay, less than 10. Negative 3 multiplied by x equals negative 3x. Negative 3 multiplied by 3 equals negative 9. I will switch the whole right side into the left side to be like this. X power of 2 plus 6x plus 9 minus 10 plus 3x plus 9, all less than 0. X power of 2 dropped down. 6x and 3x equals 9x. 9 minus 10 plus 9 equals positive 8, less than 0. So x, by using the calculator, x equal negative 8 or x equals negative 1. This is the roots of the equation. Okay, now I'm going to write the number line like this. Here we have negative 8 and negative 1 here. Don't forget the infinity and the negative infinity. Okay, in between, opposite to x power of 2, x power of 2 here is positive, so in between there is a negative sign. Outside we have like x power of 2, which is positive. Okay, I need what? The function at x, at the function less than 0. So I'm going to take the negative only. F of x less than 0 at x belongs to from negative 8 opened and the negative 1 opened. Opened, why opened? Because I don't need the 0 value or the 0 value. I need the negative only. Okay, now the next example. Example 2, not example 1. Okay, in this example, determine the sign of the function f of x equal to x power of 2 plus 7x minus 15. Okay, and from that, in R, find the solution set of the inequality 2x power of 2 plus 7x less than or equal 15. Okay, to determine the sign of this function, okay, I'm going to solve the function f of x x power of 2, 2x power of 2 plus 7x minus 15 equals 0. So x equals negative 5 and x equal 1.5. Okay, the number line negative 5 here and 1.5 here, infinity, negative infinity. This one gives me 0. This one also gives me 0. Okay, in between, opposite to x power of 2, x power of 2 is positive. So in between there is a negative sign. Outside we have the positive sign. So the sign is positive at x belongs to R minus negative 5 and 1.5 closed. Why closed? Because I need all R except zeros and except the negative, so it must be closed. And it is negative at x belongs to from negative 5 to 1.5 opened. Why opened? Because I need the negative only without the zeros. And it's equal 0 at x belongs to, now I'm going to take the zeros. The zeros are negative 5 and 1.5, but inside set 1.5 comma negative 5. Okay, now to find the solution set of the equation, of the inequality, I'm going to send 15. It will be 2x power of 2 plus 7 x minus 15 less than or equal 0. So I need, this is the same function, I got its sign. So I need the negative and 0. Again, I need the negative and 0. I need this one and this one. So the negative and 0, it will be from negative 5 closed to 1.5 closed. So the solution set equal, or the function less than or equal 0 at from negative 5 closed till 1.5 closed. And this is the end of the video. I hope it was helpful for you. See you in the next video, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was